welcome Tirthankar Lahiri. You're an Oracle Senior Vice President and responsible for very cool technologies at Oracle like vector search and scalability and many things that I'm very interested in. Thank you for having time for us and joining DOAC TV.
Oh, thank you for having me. I'm very excited to be here.
Oh, very cool. I'd like to talk to you about, or with you about AI assisted database operations. What does Oracle have in its portfolio to support the DBA or database operations in their daily work or in their concepts?
That's a very good question. Oracle actually has a lot of AI technology. We've had Oracle machine learning now for a while. Oracle database contains a number of algorithms which you can use to train models and then make inferences based on actual scenarios. And we have recently added something called AI vector search, which essentially takes much more complex entities and concepts, things like documents and maybe relational metadata, and converts that into a vector, which then can be used for similarity search. All of these are tools that can be used in the toolkit for AI-based predictive maintenance and operations management, etc. We've been actually using AI in autonomous database for a long time now. Autonomous database is, self-securing, self-repairing, self-driving, largely through the power of AI. Things like automatic indexing is based on AI-powered algorithms to optimize performance. But there's a lot of technologies that are available to the DBAs, to users, end users now in Oracle database, that they too can leverage AI to assist in their day-to-day administration of the database. Any specific areas that you think we should focus on?
I think the first interesting question is when we talk about the AI framework. It's part of DBMS Analytics, right?
Mm-hmm.
How can we use that for a database administrator who is not a data scientist, but he has lots of data in performance and application sense?
Yes.
So how can we do that?
That's a very good question. Actually, AI vector search puts a very powerful tool now in the hands of essentially any person. They don't have to be data science specialists. So imagine taking AWR reports, which are basically large text documents. You could imagine vectorizing those documents and using those documents within a RAG pipeline to converse the LLM. So you might ask the LLM, with the augmentation from the document of AWR, ask it what it thinks the problem areas might be in the database. That's just one example of using AI vector search in a very simplistic way. There are definitely real-world use cases today where people are vectorizing essentially incident reports that could be very complicated, very complex, actually not complicated, many different attributes and a lot of textual interactions between the support agents and the end user, converting those into text files that can be vectorized again and again used in sort of matching with similar incidents.
Where would I typically get a LLM for that? Because I need a model to vectorize it.
Well, there's two different things. First of all, you can actually go very far without an LLM, just to say, hey, what was a similar incident that happened in the past? So if I take a system snapshot of various metrics, such as AWR, and I collect all of the other support incident data that my user entered, I could vectorize all of that and just do a simple similarity search with pre-existing events. Mm-hmm. And then maybe use that to look at what the resolution was before and say, maybe I can use the same or similar techniques to solve this particular problem.
Can I define the dimensions for the vectors myself?
Vector, we don't legislate the vector embedding models you need to use. You can use open source models, you can use paid models, you can build your own model. In many cases, for something like this, it's possible to just convert your AWR data into custom vectors, for instance. You could also do that. Mm-hmm. Again, this is still very early stage, so we're still learning as we go how people will use vector search. But we do think a combination of deterministic techniques, AI-powered techniques, can be used to generate vectors that can summarize very, very complex scenarios that a system administrator can then use to basically look for similar patterns that might have occurred in the past. I do think, especially when people manage more and more systems, AI-powered assistants can really streamline the workload of the administrators. Nowadays, DBAs don't manage one database, they manage hundreds of databases. And being able to summarize across the entire fleet of databases the performance characteristics the workload trends, etc., and being able to vectorize that data and then running similarity search matches, that could enable a new class of administration that really uses AI as an assistive tool. One thing about AI-based assistance is it's always important for the conclusions of AI to be explainable. So when we look at these results of AI, it'll be the desirable goal is whatever you generate, somebody can say, yeah, that makes sense because of these particular factors.
And it has to be in a complexity that the human still can understand and validate. Because if you get a result that you cannot grasp, then it's a problem to decide if you believe it or not.
Yes. By the way, that is a challenge with things like neural networks, because the vector that you get for an incident is based on sophisticated multi-level convolutional neural networks, and those are very difficult to explain the result of. Basically, they're large matrix multiplications. But there are ways to, again, there's a number of techniques that are developing in AI where you can actually validate the results and compare them with previous results and say, okay, well, this one is been classified as a problem because in the past a similar pattern also caused the problem. So that's where having some training data and reference data is useful in generating something that you can validate as a human being. Okay. But I think it'll be a very interesting experience to see how essentially robots assist DBAs in some sense. That I think that day is maybe not here right now, but it's certainly imminent. It's coming.
No, I think especially in this early stage, it's not yet a make or buy decision because there's nothing you can buy.
Right.
So you have no assistance. So is there a chance for the average DBA to use AI technology, raw technology, like the vector search or like the Oracle AI framework for their own use? Without a tool that's prepared, that's from out of stock?
Again, there'll always be pioneers who develop technologies themselves based on the tools we have. I'm certain that we will develop and make certain things easier for the DBAs also to provide.
So like auto-indexing, for example.
That's a good example. Things like that, just classifying scenario. This is good, this is bad. If you get wait times exceeding a certain level, we already have things like automatic database diagnostic monitor, ADDM. You can see probably more automation in that space and being able to sort of build your own ADDMs that are more specific to your scenarios. Maybe there are times of the day when you do not want backups taken because it'll disrupt your mission critical applications. So being aware of your own requirements and being able to fine tune the generic frameworks with your requirements, I think will become something that we will start to do more and more of in the future.
Okay. One field I can think of that might be very interesting because it's based on a lot of data is security.
Yes.
When you think what a nightmare it can be to read through audits, through audit logs, that's you will never find the problem. But this is something I would guess AI could help a lot.
AI can certainly help with looking at, for instance, data patterns and saying, well, is this data confidential? Is this data PII? So maybe proactively detecting PII in schemas could be something AI could help with, and saying, well, this data needs to be redacted or this data needs to be restricted access because this contains people's PII information.
Okay, so more or less AI-assisted policy making. So
could be, yeah. So AI could detect. We have all the tools in the database to secure your data, but often, especially very large numbers of databases, there is human error, and also people miss things because there was unanticipated use of maybe confidential information. Those are things AI can detect, and maybe AI can be used to detect things like suspected patterns of queries. Why is this? Why is suddenly someone dumping all the credit card numbers into a file? So being able to detect unusual query patterns and blocking access based on observed anomalies from normal access patterns, those are things AI can certainly help with. Saying, hey, this person doesn't normally need to run this query. Why is this person suddenly dumping everybody's personal information into a file?
So you could dynamically create SQL firewall.
Yes, correct. Yeah,
by that,
right. Exactly. You could. Yeah. Again, Oracle has a lot of this already today, especially with autonomous database. And but I think over time, a lot of these capabilities will be things that people can custom build as well to meet their own requirements for specific use cases. Okay.
Is there, when it comes to research in a way of analytics data or something that is going on with large customer database with large customer data. What does Oracle do to support people with dealing with their own big data sets? Not naturally unstructured data, but large data sets. Is there something Oracle helps them with to deal with AI assistants?
Well, I think this, like I said, this is still very early stage, and
Okay.
Oracle, I think, has all the mechanism that's required to manage large data at scale. The AI-powered assistance is something that will evolve over time. I think, again, just being able to introspect the data and being able to detect, well, this data is actually very sensitive, or maybe detecting pieces of data that are really hot and should be in a different storage tier, for instance. Data classification, data categorization, those are things that AI could definitely be applied to in the future, especially with very large databases where the active data is sometimes a small fraction of the overall database, but the overall database contains extremely important data that is business critical. Data introspection, data analysis, and just overall data governance is something that AI could definitely be used for in the future. Like I said, I think we're in the very early stages of this right now, but this data robot essentially of actually that's a company that already exists. Sorry, but let's say a database management robot infrastructure will definitely be something that comes up. That comes up as something that we provide as table stakes.
So it sounds to me as a technology guy, and you're also a technology man, that the building block of having a vector search engine and having any other analytics or AI capacities in the database, that will take a lot of computing power in the future. Are there ways Oracle is going to make this computing more efficient? Are you going to support CPU models and CPU types that enhance AI capability with your products?
Well, our job, what we always do is we try to make every algorithm as efficient as possible. And that's the best way to address the compute requirements of AI workloads. The good thing is CPUs are also becoming much more powerful. The core counts, keep increasing. There will also be the use of GPUs, especially on a cloud scale, where GPUs can be shared between multiple, database endpoints for providing like a consolidated service. But compute efficiency is, one of the fundamental requirements of AI processing. Otherwise, you'd end up burning a lot more CPU just to manage your infrastructure than to actually run it. We don't want that. We want this AI assistance to be as lightweight as possible. So for instance, for AI vector search, we have very sophisticated vector indexes that essentially can, navigate billions of vectors in milliseconds. When you have something like that, then the overheads of AI become much more palatable, especially for something like vector search. Now, training a model, generating vector embeddings, those are going to be CPU intensive. That's the nature of the game. But I think the overall goal will be to make the whole pipeline as efficient as possible.
Yeah, I think it's an impressive enterprise to embed something like AI into a database, because the database is a good target for that, because all the data is there by
Yes.
definition, but having the engine for that in the database itself it's a very cool thing to have. Are there things you can share that were challenging by implementing that into the database
Well,
itself? Because it's an entirely new field for everybody.
it's a completely new field. Like I said, I'm talking about something that doesn't quite exist yet. So I have to imagine where things are going to be in 10 years. If I come back to the wagon in 10 years, where we might be.
Yeah.
I do think a database native AI assistant, it's going to happen in some form or the other. It'll be like, Siri for the database, essentially, that can actually be integrated with the database and also integrated with the data itself. It'll know the schema elements, what the different data elements actually mean, what they're used for, and how to predict when something might go wrong based on the observed access pattern. Resource depletion issues over time. AI can be used to detect seasonality of resources, saying, okay, well, during Thanksgiving in the US, you are going to have a big spike in purchases.
Yeah.
So preemptively allocate more resources to handle certain class of workloads. Those are all things I think that will happen over time as part of this. We need a good name for this technology. We need a database resident robot, let's call it. I like the word robot in some way.
Yeah,
But,
because it's a worker that works for you. That's a definition of a robot, right?
It's a robot, yes. It's a highly tuned, specialized entity that looks at the entire context of the workload, the data, the access characteristics, the access patterns, and makes recommendations and takes actions based on observations. I think, the initial stages, it's going to begin by making recommendations, not by actually taking actions.
Yeah.
Over time, before you trust it's like self-driving vehicles, right? Initially, self-driving vehicles are only able to really do automatic cruise control on the freeways. Over time, they get better and better. They can start doing things like obey traffic signals. It's a bit like that with truly self-driving technology for databases, where we're going to begin with the basics and over time open up more and more of the data management work, life cycle to the AI. But I think that's going to happen. It's coming in whether at in some not too distant future.
Yeah, I'm curious when we will have first time a AI supported cost-based optimizer, for example. That will be very interesting as soon as we get there.
Well, to me, we already have that to some extent, because if you look at what AI basically is intelligent search and intelligent state space exploration. The cost-based optimizer already does that to a large extent. Now, can you make it better with AI? That remains to be seen. I don't know. Like I said, the cost-based optimizer uses heuristic AI. Whether it can in the future use generative AI, that remains to be seen. I don't know. It's possible. But again, I'm kind of an old-fashioned person, and I like things that I can explain. So when I ask an LLM for an answer, I know I'll get an answer no matter what. I just have no way to know if it's the right answer.
It will never say, I don't know.
Exactly. It never say, I don't know. Yeah. Whereas with the cost-based optimizer, I can kind of tell, well, based on the statistics and the histograms, this is the query access plan cost, and that's why it picked this join order.
You could do the calculation yourself.
I sort of like that because I can understand why it had a certain response. But having said that, we'll see. The future is wide open. And there may be a time when you could augment the optimizer with additional AI techniques. I don't know. Right now, it's still too early to say. But I think we can check back in DOAG 2030 something, let's say, and we'll see what happens then. Maybe we can reference this particular conversation then, and then see how far we've come at that point.
I think that's a good final point.
Yeah.
Thank you very much for joining us today, for spending your time with us.
Okay.
I'm looking forward to the conversation in the 2030s.
Okay.
And let's see what happens until then.
All right.
Thank you very much, Tirthankar.
Thank you.